Hello everyone. In this video I am going to discuss about solution of Cauchy homogeneous linear differential equations. We can say Cauchy homogeneous linear differential equations or Cauchy-Euler homogeneous linear differential equations. Let us discuss the method. Cauchy homogeneous linear differential equations. We can say Cauchy homogeneous or Cauchy-Euler. We can also say Cauchy-Euler. Now, what is Cauchy-Euler linear differential equation? Now, it is of the form Cauchy-Euler linear differential equation is of the form like this. This linear differential equation is known as Cauchy-Euler linear differential equation, or you can say Cauchy homogeneous linear differential equations. It is of the form x power n into d power n y by dx power n plus some constant into x power n minus 1 into d power n minus 1 into y by dx power n minus 1 and so on equals to q of x. Now it is a linear differential equation with variable coefficients. Now any differential equation of this form is known as Cauchy-Euler linear differential equation. Now, to solve this differential equation, we try to reduce this to linear DE with constant coefficients. This is known as Cauchy-Euler linear differential equations. This can be written in operator form as like this. This can be written in operator form as like this. Already we were discussed how to write a given differential equation in operator form. This can be written in operator form as like this. This differential equation is known as Cauchy-Euler linear differential equation. Now clearly it is a linear DE with variable coefficients. To solve this one, we reduce this to linear DE with constant coefficients. Then only we can solve, because we can solve this differential equation by reducing to linear DE with constant coefficients. Let us discuss how to solve this one. This differential equation can be reduced to linear DE with constant coefficients using the following substitutions. Using this substitution, we use this substitution in place of xd we write theta, in place of x square d square we write theta into theta minus 1, in place of x cube d cube we write theta into theta minus 1 into minus theta minus 2 and so on. We use this substitution. X power n d power n can be written as theta into theta minus 1 into theta minus 2 and so on, theta minus n minus 1, where capital D is nothing but d by dx, capital theta is nothing but d by dz. We are changing independent variable to z. Now in this differential equation, independent variable is x. We are changing that to z using these substitutions. Using this substitution, this differential equation reduces to linear differential equation with constant coefficients. So we can use a earlier method to solve this differential equation. Now let us discuss an example. Solve x square d square 2xd minus 12y equals to x cube into log x. Now this is the given differential equation. Now clearly it is a linear DE with variable coefficients. This is a linear differential equation with variable coefficients. This can be solved by reducing it to linear DE with constant coefficients. Clearly it is a Cauchy-Euler linear differential equation because it is of the form x power 2 into d power 2 plus some constant into x power 1 into d power 1 and so on like that. So this linear DE is known as Cauchy-Euler linear differential equation. Now we reduce this to linear differential equation with constant coefficients using the substitution. Now this is the given differential equation: x square d square plus 2xd minus 12 into y equals to x cube into log x. Now this is a Cauchy-Euler linear differential equation. It is a Cauchy-Euler linear differential equation. Now let us reduce this to linear DE with constant coefficients. Clearly it is a linear DE with variable coefficients. Now the substitution is, put x equals to e power z, or we can say z equals to log x. In place of xd we can write theta. In place of x square d square we can write theta into theta minus 1. Now where capital D is nothing but d by dx, theta is nothing but d by dz. By writing this substitution, these substitutions in this differential equation, this differential equation reduces to linear DE with constant coefficients. Let us write that. Let us say this is 1. 1 becomes, by writing all these substitutions, in place of x square d square we can write theta into theta minus 1 minus 2 into theta. Let us see what is the given form. This is plus 2 into xd. In place of xd we can write theta. In place of x square d square we can write theta into theta minus 1. In place of x we can write e power z. In place of log x we can write z. Then this 1 becomes like this into y equals to, in place of x cube, in place of x we write e power z, x cube, log x is nothing but z. Now 1 becomes like this. We need to simplify this one. Theta square minus theta plus 2 theta minus 12 into y equals to z into e power 3z. Now simplify further. Theta square plus theta minus 12 into y equals to z into e power 3z. Now clearly it is a linear DE with constant coefficients. Here theta is nothing but d by dz. In this case, independent variable is z, dependent variable is y. We are reducing a problem with variable coefficients to a problem with constant coefficients. Now already we were discussed how to find solution of linear differential equation with constant coefficients. Now let us find a solution of this problem. To find solution of this problem, first we need to find complementary function. To find complementary function, we write auxiliary equation as like this. Auxiliary equation is given by f of m is 0, that is nothing but m square plus m minus 12 equals 0. It is a quadratic equation in m. Solve this one. We get m equals to 3i minus 4. Now these two are the roots of this auxiliary equation. Clearly the roots are real and distinct. Now we write complementary function as like this. Complementary function is given by c1 into e power 3z we write plus c2 into e power minus 4z we write. Here independent variable is z, so in place of x we are writing z here. Now this gives complementary function of star. where C1 and C2 are arbitrary constants. Now let us find a particular integral of this problem. Particular integral of star is given by 1 by f of theta into q. Here 1 by f of theta in this case is theta square plus theta minus 12. So let us write that here, theta square plus theta minus 12. Now this is z into e power 3z. Now it is of the form 1 by f of d into q. Now it is of the form 1 by f of d into q. Here q is of the form x power m into some e power ax, like that. E power ax into v. It is of the form like that. So we use whatever method we were discussed in earlier videos. We use that method to find particular integral of this problem. It is the form some x into e power ax. Now let us use that method. The method says that simply replace d with d plus a. In this case we replace theta with theta plus a. Now put here theta equals to theta plus a. Then write down this e power 3z aside, 1 by, in place of theta we write theta plus 3. In place of theta we write theta plus 3 into z. Now we need to simplify this one. E power 3z 1 by, using a plus b whole square formula, theta square plus 6 theta plus 9 plus theta plus 3 minus 12 into z. Now let us simplify further. If we simplify further, we get e power 3z into 1 by theta square plus 7 theta we get. 12 can be cancelled. We get like this. Now it is of the form some x into f of d. It is of the form some x into f of d. In this case, method says that we take out least degree term outside and we write in the form 1 plus some function of d. Then we can find particular integral. So in this case also we write in the same form. Here let us take out least degree term outside here. We write like that. E power 3z. Here we take out 7 theta outside. By writing 7 theta outside, we get 1 plus theta square by 7 theta. Further, if you simplify, we get e power 3z, e power 3z into 1 by 7 theta. This is nothing but 1 plus theta by 7 whole inverse into z. Now let us use one of the formulas. We use this formula. This formula says like this, and so on. We write up to first term because here z is there. Z power is clearly 1. So this can be further written as like this. E power 3z 1 by 7 theta 1 minus theta by 7. We will not write other terms because of this z. Z power is clearly 1. Let us simplify this one. E power 3z into 1 by 7 theta z minus 1 by 7 times theta of z. We know that theta is nothing but d by dz. So d by dz of z is simply 1. Let us simplify that by writing like that. E power 3 into z 1 by 7 theta. So z minus, we get 1 by 7. Now 1 by theta is nothing but integration. This is called inverse operator, integral operator. So 1 by theta of z is nothing but z square by 2. So you write down like that. If you write like that, we get e power 3z into 1 by 7. 1 by theta of z is simply z square by 2 minus 1 by theta of 1 by 7 is 1 by 7 is constant. So we get like this. Now this gives particular integral of star. Now particular integral of given problem is given by, first we write particular integral of star. What is star here? Now star is the reduced differential equation. We have reduced Cauchy Euler linear differential equation to like this. Now this is star. This is a linear differential equation with constant coefficient. So solution of this star is given by complementary function plus particular integral. The complementary function is c1 into e power 3z plus c2 into e power minus 4z. Now this plus pi, that gives the solution of star. Now let us write that. Solution of star is given by, general solution of star is given by complementary function, that is c1 e power 3z plus c2 e power minus 4z plus pi. Pi is 1 by 7 times e power 3z into z square by 2 minus z by 7. Now this is a solution of star. Now we want to find solution of given differential equation. Solution of given differential equation is given by replacing z with log x. This is substitution we have used. X equals to e power z or z equals to log x. In place of z we write log x. In place of e power z we write x to get the required solution. Now general solution of, or you can say required solution. Required solution of 1 is given by y equals to, now in place of e power z we write x, so c1 into x cube we write plus c2 into, we get x power minus 4, because e power minus 4z can be written as e power z whole power minus 4 like that. E power 3z can be written as e power z whole cube like that. So we get like this, 1 by 7 times x cube, 1 by 2, in place of z we write log x whole square minus 1 by 7 log x. Now this gives the required solution of the problem. Now this is the solution of Cauchy Euler linear differential equation. Now how we find this solution? First we reduced Cauchy Euler linear differential equation to linear DE with constant coefficients. Then we got this solution. Thank you.